everybody, and welcome to this video on trig equations. In this video, we have a look at getting the general solution for a trig equation. So let us have a look through the steps. So the first step over here is to find the reference angle. So the reference angle is the single angle, and please watch the previous video on how to obtain that angle using the inverse trig function. Once we have that angle, we're then going to apply the corresponding general formula. To apply the general corresponding formula, we look at this Cartesian plane over here. So this has been split up into the 4 quadrants where we have C, A, S, T, telling us that in the first quadrant, all of our ratios are positive, the second one only sine, the third one only tan, and the fourth one over only cos. Now, in each of those, we have what is the general formula. So in the first quadrant where everything is positive, so all of them will have this general solution, is that it's the reference angle, so the one that we found in the first part, plus k times 360 or 180 degrees, where k is an element of integers. Now this 360 degrees would be for the cos or sine graph, because that is the period of the cos or sine graph. The 180 degrees is referring to when we are working with a tan graph, because the period for a tan graph is 180 degrees. In the second quadrant, only sine is positive. So if you're looking where sine is positive, then we'd use the solution for the first and second quadrant. And then we use the general solution 180 minus our reference angle, plus k times 360 or 180, depending whether we're working with a sine, tan, or cos graph. In the third quadrant, where tan is positive, we use the formula 180 plus our reference angle plus k times 360, where k is an element of integers. And finally, we have in the fourth quadrant, where cos is positive, 360 minus our reference angle plus k times 360 or 180, depending whether we're working with tan or cos. So the second step is to see whether it is positive or negative, and then use the corresponding general formula and then write out all valid solutions. So this part over here, if we just had to break it down, this is what we've been doing in the previous video, just getting the first angle. And then this part here is accounting for all the repetitions. So in the very first video, we spoke about what makes trig graphs different, and it is that the answer repeats every period of the trig graph. So by adding this k times 360 or k times 180, we are repeating it, going for all values forward and for all values negative. Okay, so let us have a look at some examples on how to do this graph. If you would like to, you can pause it and try the steps by yourself before going through the solution together. So here we have our first example, which has 2 sine theta is equal to 1. Now, first of all, we're going to get our reference angle, so we're going to solve for theta. So what we're going to have to do is get the trig ratio by itself. So we want sine theta by itself. So what we have is that sine theta is equal to 1 over 2, dividing both sides by 2. The next step is the one that we've spoken about in our previous video, is how to get the angle. So we take the inverse angle on both sides, the inverse ratio. So that is sine to the power of negative 1 over half. And then what we get, theta, which we call our reference angle, is equal to 30 degrees. Okay, so we can see sine is positive. So we ask ourselves, where is sine positive? So sine is positive in the first and second quadrant. So we're going to write the solution for the first and second quadrant. So in the first quadrant, our solution is our reference, that our theta is equal to. So our answer is theta is equal to our reference angle plus k times, and in this case it's 360 because that's the period of sine. So theta is equal to, our reference angle is what we solved for over here, So we can substitute it in. So this is 30 plus k times 360. So that is the general solution. All that's left for us to write is that k is an element of integers. Let us do for the second quadrant. For the second quadrant, the formula is theta is equal to 180 minus your reference angle plus k times 360. Again, it's 360 because we're working with the sine. So we have theta is equal to 180 and our reference angle is 30 plus k times 360. So then what we get is theta is equal to 150 plus k times 360. So this is one way of getting both of our solutions. You're more than welcome to use another way if you feel more comfortable with it. But we're going to repeat this method again, but I would like to show you how to deal with a negative answer. So there's the steps. We find our reference angle, determine which general solutions that we have, and then write out those general solutions, remembering to write that k is an element of z. So the second one, we're going to make cos the subject. So we have to divide both sides by a negative. So we have that cos theta is equal to minus 0.5. Now there's two ways of doing this. Is with the negative angle, we either find the reference angle of the positive part and see where is cos negative, or we find the reference angle of the negative one, which is obtuse, and write where is cos positive. Either method will be fine. I'm going to use the one where we ignore this negative. So we deal with negative later. So that's the method that we'll be using now. So how does this work? Is then when we're finding the angle, our reference angle, we say, so we use the inverse function. So cos inverse cos of theta is equal to cos inverse, but we're just dealing with the negative later, so we're only writing 0.5. Okay, so please take note is that we're dealing with the negative later, so here it's a positive 0.5. Okay, so then that gives us that our reference angle, or the first solution, is at 60 degrees. Now we have to say where, now we're dealing with the negative, we're asking ourselves, where is cos negative? Where is cos negative? For this one here, the first question we asked, where is sine positive? And we got the first and second quadrant. So here we're asking ourselves, where is cos negative? Because cos was negative and we're dealing with it now. So cos is negative in the second and third quadrant. So the second and the third quadrant, because it's positive in the first and second, fourth and first, so that means in the second and third it is negative. Then we write the general solution. So for the second one, it's 180 minus your reference angle plus k times 360, because that's the period of cos. So this is theta 180 minus 60 plus k times 360. So this here is theta is equal to 120 plus k times 360, and that is our one solution. Don't forget to write that k is an element of integers. And then the second one is theta is equal to 180 plus your reference angle, because that's a general formula for the third quadrant. So this here is 180 plus 60 plus k times 360. So then we get that this here is 240 plus k times 360, and that is our second general solution, where k is an element of integers. Okay, so those are the steps. Number one, we find our reference angle, and we've gone over how to do that in the previous video. So please revise trig equations video 2 if you're unsure about that. Then we applied the corresponding general formula by seeing which quadrant is the ratio positive or negative with in, depending on what was the question. And finally, we write out our solutions of that. So just a graphical representation of the solution, just so you know what it means. So let's do for the sine one. So this here is our sine graph. okay, a sketch of our sine graph, and it kind of repeats. So what happens is we have a solution at 30 degrees of whatever we're solving for. So let's say that's 30 degrees and at 150. So let's say that's 150. So our answer occurs at, so we were looking at where is it equal to a half. It happens at 30 degrees and it happens at 150 degrees. But you see that solution only applies to the first sine graph. So can you see this 30 and this 150 is where sine is equal to a half in the first 360 degrees. But then you see the next sine graph, this here happens, it is a half again, and this occurs at 360 plus 30, so this here is at 390, and this one here occurs at 360, so 360 degrees later, 150, and that would be for 510. Okay, so those are that's how we interpret the solutions, the general solution. So then the next one happens 360 degrees later. So we multiplied with 2 times 360 plus 30, and that's where the next solution would be. And likewise, if we have a negative value, so when k is negative, we're finding the solutions that are over here and over here. So that is very important that a trig solution repeats and the general solution accounts for all of those repetitions. Please watch our next video on how to get specific solutions for trig equations, and also watch the previous ones if you're a bit unsure.